Hello guys, this is Roshan Kumar from ISA Training Solutions. I am here with one of my trainings, Cloud Performance Engineering and DevOps. So this video will be an introduction to the training course details. But before that, we'll go over software development and deployment evolution. So let me introduce myself. So I have 13 plus years of experience in IT industry, mostly in performance engineering and Java development. I am a certified architect associate cloud professional. I have also been involved in automation using Java, PL SQL, Shell scripting and Selenium. Currently I am working as an SRE. This will be the agenda of our discussion. We'll be going over software development and deployment evolution. We'll also see how performance engineering fits into DevOps. We'll look at microservices architecture and how it is different than monolithic applications. We'll go over containers and finally over cloud computing briefly. Before we get started with software development and deployment evolution, so let me ask you a question. So, how many of you would agree that performance engineers are expected to know this? DevOps, microservices, containers, and cloud. So, to put things in context, let's go over the next slide, which is software development and deployment evolution. There has been a lot of change in the development and deployment since 80s till now. We can trace the evolution of how organizations have developed, deployed, and managed applications over three distinct phases. Back in 1980s to mid 90s, and then mid 90s to early 2010, and then 2010 to the current scenario now. Back in 1980s to mid 90s, so data centers with physical servers running monolithic applications developed using traditional waterfall model. So that was the case back in 1980s. But during mid 90s and 2010, data centers and hosting providers running Unix, Linux servers, but with virtualization coming into picture, with VMware and KVM as major players running end-tier applications developed using agile model. And from 2010 to present scenario, as we all know that cloud increasingly replacing data centers and hosting, decomposition of applications into microservices running on container infrastructure, managed and orchestrated by Kubernetes, developers and operations collaborating using DevOps model. So we'll go over all these things in quite briefly and in detail as well for a few other topics. So let's understand first how this performance engineering fits into DevOps. But before that, let's how DevOps came into existence. So we need to figure out that first. So as we saw in the last slide, before adopting DevOps, we have been using waterfall and agile model for software development. Software waterfall model is a straightforward and linear model where performance testing is carried out just before deploying the application in production. So many a times performance testing was overlooked because of time constraint. In general, this approach was not efficient and resulted in applications not meeting performance SLAs. And eventually, performance issues were mitigated by expensive sizing methods rather than code optimization. Next came into agile model where software development is broken down into phases called sprints, right? Different sprints, and this model promotes continuous iteration of development and testing throughout the SDLC of the project. Both development and testing activities are concurrent in this agile model, unlike the waterfall model. While the agile approach brought agility to the development, it was lost on operations side, which did not come up to speed with agile practices. So there was a lack of collaboration between developers and operations engineers, and this slowed down the development process and releases. Software companies had begun to realize the need for better collaboration between the teams and faster delivery of software. This gives the birth to DevOps approach. DevOps enabled continuous software delivery with less complex problems to fix and faster resolution of problems. So when I talk about DevOps lifecycle, so I basically mean about the continuous development, which is this phase, plan continuous development, and then we have continuous testing here, And then we have continuous integration, and we have been using tools like Jenkins here for the continuous integration, and then we have continuous deployment, and then we have continuous monitoring. So coming to integrating performance engineering with DevOps. So idea is to engage performance engineering activities in the continuous testing, and continuous monitoring phase of the DevOps lifecycle. Engaging performance engineering activities in the development phase enables earlier detection of performance issues and improve overall quality and maximize delivery velocity. Here, performance requirements are to be analyzed and use cases are to define with development objectives. This approach is called shift left approach. Performance testing is integrated in testing phases as usual. Here we can leverage Jenkins to create jobs to automate the testing process, hence the name continuous testing. Performance testing as part of CI/CD process as an important element of a successful performance engineering practice. However, by itself, it will not be sufficient to continuously adjust to changing patterns in the performance behavior of applications. Performance monitoring as part of shift right strategy is the other important ingredient. It will help to understand the behavior of the production systems and end user experience, which is crucial for adjusting load testing scenarios and overall performance engineering parameters. So basically, what I'm telling is we have to engage performance engineering in continuous development and continuous testing and continuous monitoring as well. So that's the approach of integrating performance engineering in this DevOps lifecycle. So coming to my next slide, so applications are moving from being monolithic to being microservices. The monolithic applications describes single tiered in which all the business logics are combined into a single applications, tightly coupled. Whereas microservices are where each business logic is running as an independent application with database. In microservices, we run all the applications on containers. So one of the popular containers are Docker. So the boot up time and memory consumption of application decreases, thus the performance of the application increased. So to explain this thing further, so here we can see that in the monolithic architecture, so all the web components, all the application components, whether it's the web server or the application server or the DB server, all are tightly coupled. Whereas in the microservices, so we have split the business logic into various segments, and the best part of microservices is that it is not platform or in or language dependent. So one of the microservices can be developed in Java, another can be developed in Python, another can be developed in Golang, some different language. But whereas in the monolithic architecture, platform is specific. Yeah. So let's understand this with an example. So let's take this example of bookstore app where we have this accounts, payments, shipping, and inventory in this bookstore app. If we want to develop this using monolithic architecture, so all these business logic will be tightly coupled. And suppose if something goes wrong with my accounts, the entire system goes down. And to fix this, we have to build the entire code all over again. Whereas in microservice architecture, all since all these business logic is loosely coupled, accounts, payments, shipping, and inventory. So if something goes wrong with accounts, my payments, shipping, and inventory is still up, and we can easily fix this account. If we have any failure in account section, we can fix this account section without touching the other modules, payment, shipping, and inventory. So that's the best part of the microservice architecture. Coming to the containers, so what are containers? Containers are the runtime environment for microservices. Containers virtualize at the OS level. So containers virtualize the OS instead of virtualizing the underlying computer like a virtual machine. They sit on top of a physical server and its host OS, typically Linux or Windows. Each container shares the host OS kernel and usually the binaries and libraries too. So that's the main reason why containers are getting so much of traction, because it uses the underlying host OS. And suppose in this case of VMs, we have suppose app A, app B, and app C. Consider this as the enterprise server, this as the web server, and this is the DB server. So we had separate OS installed for all these event components. But whereas in containers, we just have the host OS, and on top of that we have Docker engine installed, and the binary and libraries are common across all the event components. So yeah, it's very light and it boots up in second and takes fraction of disk and memory. And we have popular containers, Docker, and container orchestration engine as Kubernetes. So we'll be going over detail in our course. And coming to the last topic of cloud computing. So the cloud computing, the idea of it, cloud is getting traction over the period of time now, and currently most of the companies are trying to deploy their application in cloud, and because of its regions. Because if we talk about this is the on-prem model. So where all these components are all data centers, networking, storage, servers, virtualization, operating system, databases, security, and application, all these things are hosted in the data center. So, and whereas if you want to use the cloud services, where like IaaS, infrastructure as a service, or platform as a service, or software as a service, so we can leverage this the cloud offering, and we can achieve so much. We have deployment models also in cloud: hybrid model, public model, community model, and private cloud model. So this is the course topic, uh, which will be covering in the training journey. And so we'll start with software architectures and how performance engineering in DevOps. We'll be looking into Java for performance engineers. Cloud computing, we'll be taking AWS, and we'll be going over all the cloud computing concepts. We'll be also looking into Linux command line, the container engine Docker, and container orchestration engine Kubernetes. We'll be also looking into continuous performance testing, how performance testing is done in the CI/CD pipeline, and performance test monitoring and analysis, performance, Java performance and memory management, Java collections and performance, Java multi-threading, concurrency, and performance optimization. So you can register and join us for the detailed demo. The link will be provided in the description. Yeah, thank you.